Hey, guys, how are you doing? Today I'm going to introduce some trigonometry to the grade 11 learners. So this video is for the grade 11 learners. So before I go any further, please make sure you subscribe. Thank you. Now let's start. It's loading. Let's wait. Let's be patient. Okay, now introduction to trigonometry. What is trigonometry? Trigonometry is the study of the relationships between sides, length, and angles of a triangle. So, moving forward to the overview of trigonometry. Okay, under trigonometry, we're going to talk about trigonometric ratios, identities, action formulae, something like that. So under this thing, trigonometric ratios, identities, and introduction, what we should know is that there are 6 trigonometric ratios: sine, cosine, tangent, cosecant, secant, and cotangent. Then these 6 trigonometric ratios are abbreviated as sine, cos, tan, cosec, sec, and cot. So these are referred to as ratios since they can be expressed in the terms of the sides of a right angle triangle for a specific angle theta. It's either theta, x, a. They can name it anyhow, but now let's just name it theta. So theta is measured from the positive x-axis on a Cartesian plane. So another thing we're going to look at under trigonometry is angles. By angles we mean special angles and negative angles. Then we're also going to talk about trigonometric identities, trigonometric graphs, triangle identities, 2D and 3D problems, where we are going to use the sine rule and cosine rule. Moving forward. So now let's start with trigonometric ratios, identities, and reduction. Remember, I said it is just an introduction. We won't go deep into these things. We'll go deep next time when maybe we're answering some questions, something like that. So the trigonometric ratios are for right-angled triangles. These ratios all involve one angle, the other than the right angle, and the length of two sides. So this statement means since you are going to deal with the right angle triangle, these ratios all involve one angle and the other two angles. Oh, okay, no, not other two angles, and the length of two sides. So the ratios can be used to find the length of an unknown side or an angle if the other digits are known. Means when we must use the trigonometric ratios, since it involves one angle and the length of two sides, meaning if you want to use them, you must either know the two quantities. So we have one angle and two sides, meaning we have 3 quantities. So if you want to use the trigonometric ratios, you have to know 2 quantities of the 3. Thank you. Okay, in right angle triangle, the Pythagoras theorem can also be used. This is just a hint or a reminder. Somehow we might need to use the Pythagoras theorem to solve. Moving forward, then let's get into the definition of the 3 ratios. Given angle theta, sine theta is equal to the opposite over the hypotenuse y or r. Since we are going to use this on a Cartesian plane. On a Cartesian plane, sine is y over r, but somehow these angles are namely opposite and hypotenuse. Then opposite, hypotenuse, and adjacent. So now let's get to cos. Cos theta is equal to adjacent over hypotenuse. And then tan theta is equal to opposite over adjacent. Now, how do you know that this is the adjacent side, this is the opposite, or this is the hypotenuse side? So here's our triangle and our given angle there, angle theta. So obviously the longest side, the slope longest side is our hypotenuse side. Then the other side is the opposite side. Now, how do you identify the opposite side, or how do you know that this is the opposite side? It is the opposite side because it is opposite to the given angle. I hope I'm clear, you're not lost. Then the last side is adjacent. I hope I'm not too fast or something like that. I hope you can understand. So, and then we have sec, cosec, and cot. Now, the other three trig ratios are just the inverse of the first three trig ratios. As you can see, I've underlined and changed the color of the third letter of each trig ratio. It's just the opposite of the other three. So how do you identify it? It's just the inverse, not the opposite, the inverse. Yeah, something like that. So how do you identify the inverse of cos, sine? So as you can see, sec, I've added the third letter, I have added the third letter. So meaning the third letter is C. Now let's check which trig ratio starts with C. It's cos. So meaning this one is 1 over cos theta. Now we're going to cosec. Now the third letter of the word cosec is S. Now which trig ratio starts with S? It's sine. So meaning cosec theta is equals to 1 over sine theta. So meaning you can identify the inverse of the first three trig ratios by looking at the third letter of the given inverse of the other trig ratios. Now let's go to cot. Obviously it's 1 over tan theta. Now let's move forward. We're going to do an example on how to use these trig ratios. So then our example, this is the first example. Assume we are given a triangle with angle 70 and 15 meters on the hypotenuse side. Now the question is calculate AB. As you can see, AB is our opposite side because it is opposite to the given angle. Now, which trig ratio am I going to use given the angle and the hypotenuse side? And I'm calculating for the opposite side. Now let's check which trig ratio suits me on this scenario. I want to calculate the opposite side, but I'm given the hypotenuse and the angle. It means I'm going to use which trig ratio that involves opposite and hypotenuse. So the trig ratio that includes opposite, hypotenuse, and angle is sine, because sine is opposite over hypotenuse. Now sine 70 is equal to AB over 15. Now AB is the opposite side, 15. Now the AC or the hypotenuse side is 15. Then you cross multiply, then you will get 15 sine 70 is equal to AB. Therefore AB is equals to 14.10 meters. So now you know your side AB is 14.10 meters. I hope you are not lost. You can understand what I'm trying to show you. So to the next question, calculate BC. For BC you can use either Pythagoras theorem, trig ratio, cos, or tan. Since you know the opposite side, you can use tan, or you can use cos since you have the other side, which is the hypotenuse side. So moving forward, You can even use Pythagoras theorem, because you can say now you have two given sides, and then you have two sides that have that are given. Maybe let's say that okay, yeah, the known sides, there are two. So, but let us use the trig ratios. Let us not go there to the Pythagoras theorem yet, because now I'm talking about the trig ratios. Now, if I'm using a cos 70 degrees, it means cos 70 degrees is equal to BC over 15. Cos 70 or cos an angle is equals to adjacent over hypotenuse. So now my adjacent side is BC, and then the hypotenuse side is 15. So then you cross multiply again, you get 15 sin 70 degrees, then it's equals to BC. Therefore BC is equals to 15.13 meters. Even though you can use cos, even though you can use tan, you will get the same answer. So how do I use tan? There it is, and then you cross multiply again. You do the cross multiplication, then you divide by tan. Okay, if you do the cross multiplication from tan 70 is equals to 14.10 BC over BC, you will get BC tan 70 is equals to 14.10. Then BC will be equal to 14.10 over tan 70. I hope you understand. Therefore my BC is 5.13 meters. Even though you can use the Pythagoras theorem, you are going to get 5.13. Now we're just doing the examples. You will understand more when we get back, when we go to the questions. Now I'm just passing by, showing you how to calculate it. So let's move forward. Now we have the reduction formulae. Formula is the plural form of formula. Now this reduction formulas are mostly used on Cartesian plane. This is our Cartesian plane. We have x-axis, y-axis, then 90 degrees, 180, 270, and 360 degrees. So let's start. Quadrant number 1, there is no reduction formula. All trig ratios are positive, meaning on quadrant number 1, sine, cos, tan are positive. When we are going to calculate those trig ratios or on a Cartesian plane, they are all positive. But then on quadrant 2, the reduction formula is 180 minus 90 degrees. Minus theta, sorry. And on quadrant number 2, only sign is positive. I hope you understand. So on quadrant number 3, it's 180 plus theta, only tan is positive. Then we have quadrant 4, where the quadrant 3 reduction formula 180 plus theta, only tan is positive. Quadrant 4, 360, the reduction formula is 360 plus theta, only cos is positive. You will understand it when we are doing the question. This is just the overview. So now this is a simple table to show you the reduction formulas, the reduction formulae. I meant to say sorry about formulas, not formulas, it's formulae. So under quadrant 1, as I've mentioned, where there is no reduction formula used on angles less than 90 degrees. So sin theta minus 80 degrees is equals to plus sin theta, because we said on quadrant number 2, sine is positive. Only sine is positive. So you can see if it is cos 180, cos is negative and tan is negative. So please take this table into consideration. Know this table, because you are going to use these formulae to simplify your trigonometric expressions. Then on quadrant number 3, you can see reduction formula sine 180 plus theta, then sine is negative, cos is negative, only tan is positive. On quadrant number 4, Sine is negative, cos is positive, then tan is negative. Here only cos it is positive. Now this this formula or this diagram, it is known as the cast diagram. If you read it from quadrant number 4, 1, 2, and 1, 2, 4, 1, 2, 3, because since on quadrant number 1 all three equations are positive, then we are going to use an A, quadrant number 2 S, quadrant number 3 T, quadrant number 4 C. So it is the cast diagram reading from quadrant number 4, 2, 1, 2, 3, something like that. You will understand. I hope you do. So then we have these things called negative angles. There's another table on those quadrants. Quadrant you sometimes will find them like minus sine 180 minus theta. Just know good, minus sine 180 minus theta is positive. It's still on quadrant number 2. Nothing changed. Then quadrant number 3 minus 180. Don't be fooled by this minus sign. So it's like this minus sign is not there. You see? So moving on, quadrant number 4, we have those sine negative theta, cos. Quadrant is when you get sine theta, sine negative, cos negative, tan negative. Just only cos is positive. The rest is on quadrant number 4. It's called reflection, negative angles. So adding or subtracting trigonometric function just like that, it's not going to change anything. So I hope you do get this. So moving forward, we are moving forward now. We're going to look at the core functions, sine and cos. These are the core functions of sine and cos. So core functions allow us to write ratios of sine in terms of cos and the ratio of sine in terms of cos and vice versa, meaning we can write cos in terms of sine. So when you get something like sine 90 minus theta, just know what it changes the sign. 90 plus 90 minus, not the sign, the trig ratio. 90 minus, it's sine 90 minus is equals to cos theta. Cos 90 degrees minus theta is equals to sine theta. Sine 90, just like that. But be careful when it comes to cos. Every time when sine changes to cos, it is always positive. But when cos changes to sine, when it is cos 90 minus, sine is positive. But when it's cos 90 plus, sine is negative. We'll talk more about that. Don't worry. It's just the introduction today. So then there we go. Now we're going to the last part of identities. In grade 11, there are 2 fundamental identities that you are required to know. So, which is sine square theta plus cos square theta is equals to 1. So, meaning good, using this formula, and if you want to find maybe sine square theta, you might want to make sine square theta the subject of the formula. It means good, sine square theta is equals to 1 minus cos square theta. Cos square theta is equals to 1 minus sine square theta. Then I hope you understand. Then tan theta is equals to sine over cos theta, sine theta over cos theta. These are the 2 identities that you are required to know as a grade 11 learner. So to prove sine square a, or as I said before, theta can be either, it can be changed to x, a, whatsoever. It's still the name of the angle. Nothing has changed. So then here is how to prove it. Since you know sine A, okay, now here's our Cartesian plane. You can see on the right, you have a Cartesian plane. Your opposite, okay, your angle is A. Where is A? A is here on the point of origin. Now your opposite side is A, hypotenuse C, then adjacent is B. So if you can check, C, oh okay, sorry about that. Sine A is equal to opposite of hypotenuse. Which side is opposite? It's A, hypotenuse is C. Then you can see what's happening. Then again, cos, same story. Then sine square A plus cos square A. And then they square the since sine squared A is equals to A over C. Since sine A is equals to A over C, then sine square A is A over C all squared. Same applies to cos. So then and then on the next step we have A squared over C squared plus B squared over C squared. So now you know how to add the fractions. You just give the lowest common denominator, and then apparently our lowest common denominator here is C squared. Then A squared plus B squared over C squared. So the Pythagoras theorem says hypotenuse squared is equals to opposite squared plus adjacent squared. So if as you can see, our A is our opposite or opposite side. So opposite squared plus B, which is our adjacent squared, is equals to what? Opposite is equals to it's equals to hypotenuse. And you can see from the diagram that our hypotenuse side is C. So it means we're reaching C squared. So C squared over C squared is equals to what? 1. So that's where the formula comes from. The identity comes from. Sometimes you may be required to prove, sometimes you may not be required to prove, but in most cases you're not required to prove, just for safety first. So let's go to the example. Now examples of the identities, they be like express sine theta over tan theta as a single trigonometric ratio. So sine theta over tan theta is sine theta, and then you change the tan. Since you know that tan is sine over cos, you check the tan. So sine theta divided by sine, since I need sine theta over tan theta, is sine theta divided by tan theta. So now I want to express this in a single trigonometric ratio. So I change the tan. So it's still sine theta divided by sine theta over cos theta. Now if you want to work this out, you know what, if you want to work this out, you must change the division side. Then the denominator becomes your numerator becomes the denominator, just like that. And then on your operator becomes multiplied by. So it's sine theta multiplied by cos theta over sine theta. Then your answer will be cos theta, because sine theta and sine theta, they will cancel each other, or they will give you a 1, not meaning to cancel, they will give you a 1. So then 1 multiplied by cos theta is cos theta. So it's the same thing. So moving to the last part is where you prove the identity. 1 minus sine theta, 1 plus sine theta. Then we have, it's not the last part. Let's see. We'll see. Okay, we have to prove this identity. So to prove this identity is very, very simple. You just take the left hand side. Your left hand side is 1 minus sine theta, 1, and then 1 plus multiplied by 1 plus sine theta, then over cos square theta. You have to prove that this left hand side is equal to your right hand side, which is 1. So if you can check, 1 minus sine theta multiplied by 1 plus sine theta is the difference of two squares, ne? So meaning it is equal to 1 minus sine square theta. I hope you know the difference of two squares from grade 9, if I'm not mistaken. So your identity says cos square theta plus sine square theta is equals to 1. So meaning cos square theta is equals to 1 minus sine square theta. Is from the identity. So meaning that 1 minus sine square theta, it's either I change it to cos square theta or change cos square theta to 1 minus sine square theta. But let me change it to cos square theta. So now I have cos square theta over cos square theta, then which gives me a 1. Cos square theta over cos square theta is 1. 2 divided by 2 is 1. 4 divided by 4 is 1. So my conclusion will be that therefore the left hand side is equal to the right hand side. Now I've proven this left hand side is equal to the right hand side. Simple as that. So that was the end of today's lesson. So thank you very much till we meet again next time. Thank you.